So, I claim you guys already know something about this. You guys know how this number acts. So, if I think about multiplication by 1 as a function from the real numbers to the real numbers, and Hope's gonna feel it, so I'm gonna just go like this. So if I think about multiplication by 1 as a function from numbers to other numbers, how interesting is that thing?
It takes any number you put in to the number that you put in.
Yeah, right? This would be f of x is x, right?
Is that a times by 1 or
Yeah.
a dot 1?
Times, multiply by 1.
Okay. Okay.
You should see my trig students. When we
Is
do
that-
degrees and the dots, they get super confused.
Is that a 1 or is that 3 lines?
It's 3 lines arranged to be a 1.
Just because we say.
Okay, you guys good with the idea of this function? This is really boring, right? This thing, for instance, takes the number 3 and gives you
3.
3, or the number pi over 37 and gives you
Pi over 37.
perfect. This is a really dumb function, right? This just gives you back what you started with. So the higher dimensional analogy is I want to fill in a matrix. So this is 2 by 2 idea of the same. Okay? So I want a 2 by 2 matrix that takes a vector xy and turns it into the same vector xy. Okay, see this? Okay. What goes in here?
1, 0, 0, 1.
1, 0, 0, 1. Yeah?
Yeah.
So if I pick this up, twist and drop on, right, I need to get x out. That means the y's have to 0 and the x's have to be multiplied by 1. So this is the two-dimensional analogy of this thing, right? It leaves the x's alone and it also leaves the y's alone. You guys see that? Okay. What's the 3 by 3 idea of the same?
Would that be 0, 1, 0, 0, 0, 1, 0, 0, 0, 1?
Perfect. Good. Check. Can you guys build the next one? Good. I'm not going to write it down either. So you could build the next one, and the next one, and the next one. So I'm going to call all of the matrices that look like this the same thing, because I don't really want to have to specify which dimension I'm in to talk about an idea that's so silly, right? All this thing does is return exactly what you gave it, and so I'm going to call that the identity function. These guys, this guy, those are identity functions. These ones are specifically identity matrices. This one would be the identity matrix if I did that to it. You guys see that? Right? This is a really dumb matrix.
Oh,
It's
yeah.
1 by 1. It takes 1 by 1 things to 1 by 1 things by multiplying. You guys see that? So I wasn't really lying. You've seen one of these, this one. You maybe ran across this one by accident, the 2 by 2 one someplace. Cool with this? All right, so these are the function that just hands you back what you were given. Good? Please notice when we're solving stuff, right, when we have an augmented matrix, like whatever augmented by stuff, what's our goal when we try to solve?
Basically get the identity matrix.
Yeah, we try to kind of fiddle this around to turn it into identity matrix augmented by stuff, right? And then I can read off the answers. You guys see that? Okay, so this thing's going to keep coming up. And the next spot it's going to come up is when we do inverses in like 30 seconds. So do you have any more questions on identity matrix? Okay. Oh, what's the determinant?
One
Oh,
times one
zero.
minus 0 times 0, so 1.
Okay. This one's really easy. This one has determinant 1. This one? Determinant also 1? 1 minus 0. This one? Just a wild guess, right?
1.
Probably 1. How about the rest of them?
1.
They probably have determinant 1.
Probably.
Well, that's not in evidence, but they do. We really could think about that this way. To calculate the determinant of this thing, right? I'm going to do plus minus plus, right? And then I'm going to get 1 times the determinant of the next dimension down. Plus 0, right? Okay, so if this one has determinant 1, it's because that one does. This one has determinant 1 because that one does. And the next one up will have determinant 1 because this one does. Okay, you see that?
Yes.
That's a thing called induction. It's well beyond the scope of this. Are you guys okay with that idea? All the identity matrices have determinant 1, which is why we think about matrices with determinant 1 as being a little bit like unchanging.